If we go the other way, let's see, x squared plus y squared plus z squared minus 6x plus 4y equals 9. Well, obviously, with the x squared, the y squared, and the z squared added together like that, that signals alerts you to a sphere. If it was x squared plus y squared minus z squared, or it wasn't all three added together, then that's or one of them was a cube, then that's something different. Get pretty complicated pretty quick here. I don't know the graphing TI 8384s. I haven't done much graphing 3 dimensions on it. I'm not even sure it does it. I don't think it does it, but there are calculators that'll handle it. And of course, you got Mathematica, things like that. Yeah. Google it, absolutely. But anyway, that one we recognize. So find the. So this is going to be a sphere. So to find the center, what do you think? Well, with these, we got a little shifting. Remember that? If we group the x squareds here, then do a little completing the square. Yeah. So let me space that out. Of course, the z doesn't have a counterpart, so the z squared. Yeah, complete the square, half that, and square it. Half is -3, square would be +9, so I'm going to add 9 both sides. Half that squared would be 4, so add a 4 in, so we've got, and then factor it up. Be x minus 3 squared, that'd be y plus 2 squared, plus z squared equals 22. So the center is 3, -2, 0. Radius is square root of 22. So that's similar to, okay? All right. So we're just adding in another variable, or the z. Yeah, completing the square. We've done this in 2 dimensions a lot. Now we're just going to do some of it in 3 dimensions. All right. Let's go back to the describe. We saw that z equals 3. That's a plane. X squared plus y squared equals 9 is a tube or a cylinder. What if we throw in an inequality? Got a couple of those for you. If you throw in an inequality, there. If you just look at, again, the 2 dimensions, the YZ plane here, what have we got? You got another circle, okay? So in the YZ plane, we've got a circle. A horizontal too. Okay. What about the inequality? Okay. All right, so in the YZ plane, we've got a circle. So we've got a circle here, radius 2, centered at 0, 0. It's not shifted or anything. So we've got a circle of radius 2 here. Of course, that would be x equals 0, right? X equals 0 is in the YZ plane. But then if you vary it, you've got, yeah, so that's just going to keep on making different levels. Aha, yes. So we get this tube shape. The inequality, but that's equals. So the outer part is what we're talking about there, the tube. The inequality says we want it less than or equal to 4, so the less than part would be inside that, wouldn't it? Yeah. So it's the solid tube, right? So that's what it would include. The outside tube and then everything inside. So, all right. One other thing I forgot, I think, to mention was, and again, it's just an analogous to the two-dimensional. You know, in 2 dimensions, if we want the distance between 2 points, we do, you got x1, y1, x2, y2. And so the distance between those 2 points, you got at your square root, right? x2 minus x1 squared, y2 minus y1 squared. Comes from Pythagorean theorem. Well, in 3 dimensions, let's call point P1 x1, y1, z1, P2 x2, y2, z2. And then some terminology here, or some notation, I guess, better word for what I'm showing you here. That distance between those 2 points, distance between, okay, we'll use a, looks like an absolute value, but actually it's going to represent distance or magnitude. Right. That's the notation we'll use, and in this case we called it P1 and P2. There's other, sometimes we'll have some other stuff there, but guess what? The nice thing again, it's very analogous. It's the square root of difference of the x's squared, differences of the y squared, plus the difference of the z squared. Very nice. Very nice. Okay? And actually that's where the equation of the sphere, you can get that just like you can get the equation of a circle out of that one, equation of a sphere out of that one. So, I think they have a couple of questions, you know, which they give you a triangle and which sides do you have a right triangle or a isosceles triangle. So you just calculate the lengths of the sides and then see if it's a right triangle or an isosceles.